So we developed a system that can train an agent to perform a task just by observing demonstrations. So our agent controlled a virtual hand model to perform dexterous tasks. So our system is broken down into three phases: a demonstration phase, training phase, and inference phase. So I'll first go through the demonstration phase. This is where a demonstration is performed using a Dexmo glove. Unfortunately, we did not have access to the glove, so keyboard inputs were used instead to control the virtual model. By controlling this virtual model, it will produce a demonstration file. I'll show the demonstration phase now. So to perform the demonstration phase, we must set the behavior type to heuristic. This allows keyboard inputs to control the virtual hand model you can see here. Our project was set up in Unity, and we used a libdexmo Unity SDK provided by Dexmo. The task was to touch the green target and avoid the red obstacle. So with our behavior type in heuristic, we can go ahead and perform a demonstration. This demonstration will be recorded using a demonstration recorder, and it should be named video demo. And it should appear right here after we perform the demonstration. So the actions our agent takes are the bend angles of each finger and a rotation angle of the thumb. So as you can see here, these are the bend angles of each finger, and we use these to touch the green target. And we also have a rotation angle of the thumb, which you can see here. The observation vector provided to the agent is the Y positions of the target and the obstacle. So you can see their X and Y position, or their X and Z positions are fixed. And then we provide the Z rotation of each finger. So the Z rotation is affected by this movement here of each finger. But for the thumb, we have the X, Y, and Z rotation, as they are all affected when moving the thumb. So here we're just completing the task multiple times to provide a demonstration. So once the demonstration is complete, it will appear here as a demonstration file. So you can see here we completed 12 episodes, achieving a mean of 0.91. This is because one episode I delayed and didn't touch the target. Now we've successfully performed the demonstration phase, which used keyboard inputs to control the virtual model and create a demonstration file. This demonstration file will now be used to feed our learning from demonstrations algorithm. This was implemented using ML-Agents Toolkit, which combines proximal policy optimization, generative adversarial imitation learning, and it uses behavioral cloning to initialize the policy parameters. Training is implemented using a Python API, and first we must specify the path to the demonstration file to our Gale and BC learning. So I'll show you how to implement the training phase now. The training phase is done in Unity, so the Python API controls the virtual hand model by providing the agent with actions. So the Python API requires a configuration file to specify the hyperparameters used for the PPO, Gale, and BC. So BC and Gale are pointed towards this demonstration we created, so the video demo.demo file, and these are just some of the hyperparameters we use. Just note that the behavior name must match the behavior name given to the agent in Unity. So we now call on the Python API. As you can see here, we're calling the configuration file, Gale config original, and now it requests us to press play in the Unity editor. So in Unity, we must set the behavior type back to default, and we just increase this decision period to avoid collisions breaking. So training is performed at a much higher time scale, and if we leave the decision period to 1, it might result in collisions not being detected. And we must turn off the demonstration recorder as well. And as I said, the behavior name must match the behavior name given in the configuration file. So now the agent is being controlled by the Python API, feeding the agent the inputs. So it's controlling the finger, the bend angle of each finger and the rotation angle of the thumb. And as you can see, the hyperparameters for the PPO trainer are the same as the ones specified in the configuration file. So we need to leave the training running for a very long period, approximately 700,000 steps before the policy is learned. So And then this will create a TensorFlow model containing the learned policy. Okay, so the results of the training phase are a TensorFlow model file. This contains the learned policy and represents a neural network. So this neural network is now used to provide the agent with the optimal behavior actions to reproduce the task demonstrated during the demonstration phase. So I'll just go ahead and show the inference phase now. Phase results in a TensorFlow model, which you can see here, named video demo. We must attach this model to the agent as shown and set the behavior type to inference. So now this model will be used to control the virtual hand model and perform the learned task. So now you can see the agent has learned to perform the task and is steadily touching the green target. So we've successfully trained the agent to perform the task.